Hi, welcome back. Now, I would like to first of all start by showing you going back to the original intent, which is the electric go-kart for the integrated project. Now, I'll be first of all targeting the battery temperature monitor, which is the LM335, as well as the light sensor, which I'm going to be showing you, as you can see over here. Now, the light sensor could mean that it could be used for sensing whether this thing is, whether the go-kart is actually doing a day race or a night race, much like for F1 race. And of course, the LM335 battery temperature monitoring is done through the use of this temperature sensor LM335, which monitors the battery voltage. Sorry, not battery voltage, the battery temperature. Now, to begin, now let me first of all show you going back to the Ni Max. Okay, I'm just going to use a search the Ni Max, as you can see. So the Ni Max will launch Measurement and Automation Explorer. Okay. Now, currently, what I have here is I have not connected the device, the physical device. So if you allow me, I'm clicking on the Ni Max here. Now, what I can see here is I only have a device number 1. Now, device 2 and 3 were my earlier accessions that I did. I'm going to just quickly remove them. Okay, let me see if I could remove it. Okay, I probably have to do one at a time. Okay, I delete this, right? And I'm deleting this as well. So currently, to come back from a clean slate, I have the device, which is a simulator deck, which is the USB 6009 device 1. Now, so what I'm going to do, I can do a self-test. Okay, it's passed, right? So I'm going to minimize this. Now I'm switching over to lab view, where I'm going to open a new VI. Alright, I'm just going to open a blank VI and I'm going to do a tile left and right, as you can see over here. Now remember, the intent is to use the DAQ assistant as so-called the offline mode. I'm going to use the simulated deck. So to begin, let's follow on. I'm going to put the while loop, as you can see. Right click, create a control here, which is a stop button. And let's maybe resize this stop button bigger. Okay, I'm going to press the Control plus button to leverage, to increase the size. I'm going to put 100 millisecond for the time delay. Oops, do again. Sorry, I made a mistake here. I have to right click, create a constant instead. Okay, constant. I'm going to put 100. Now, now do remember that because I'm using the LM335, okay, the output is calibrated in degree Kelvin, right? So what I'm going to do is I'm going to open up the measurement I0, right? Select the DAQ assistant, which is the normal thing that we have been doing. Right click, measurement I0, Ni my deck, DAQ assistant. I'm going to put it down. Now do remember that the temperature sensor LM335 is connected to the analog input channel 0. So as such, I need to acquire signal. Okay, I'm going to acquire signal. Now I'm going to acquire from the voltage, the voltage for this. Okay, I'm going to click voltage. I'm going to choose Ai0. Now at the same time, I also would like to acquire the Ai1 because as I say over here, I'm also trying to monitor the light sensor. Alright, so I'm going to pinch 2 of these channels, which is the Ai0 as well as the Ai1. So Ai0 for the temperature sensor LM335 and the Ai1 is the light sensor. Okay, I'm going to click finish. Now, so I need to do some configuration setting, which is supposedly not new to you. So I'm going to put the minimum has 5 and the maximum input has maximum has 5, sorry, minimum has 0. I'm going to set this to the RSE mode. As you can see, terminal configuration and also 1 sample on demand. Right. So now I have configured simultaneously 2 channels. Alright, which is the Ai0 and the Ai1. both using the simulated deck. But later on, you will see that I can connect the physical 6009 hardware and it will still work very well. Okay, with that setting in mind, I'm going to click OK. So now I can see that I have created, is building the configuration channel, and here we are. Now, so what I'm going to do is that I'm going to rename the DAQ assistant to give it something more meaningful. So I'm going to say reading LM335 temperature sensor and the light sensor voltage, okay, as well, right? Voltages, right? So I'm going to put this away. Now, what I'm going to do is next is that since the data that is coming out will be you have two components, right? So I'm going to go to the Express VI, which is over here. I'm going to use the signal manipulation and looking for this device called convert from dynamic data, as you can see over here. Alright, this piece of device, node, I click, okay, now let's come back to here, signal manipulation, take this, right? I'm going to drop this here. Now, as soon as I drop this function, this node onto the block diagram, so LabVIEW will ask me, what do you want, right? So I know it is a 1D of a scalar this time around, because it contains two components. So I'm just going to use the default setting here, and I'll wire this output to here as the input, and now this thing is an array. Now I know that there are two channels, right? The Ai0 as well as the Ai1. So what I could technically do is that I'm going to right click, use the array, under the array palette, I'm going to use this thing called the index array. Okay, index array. This is something that you should be quite familiar as well. So I'm going to use this index array. I'm going to drop this index array. I'm going to turn on the visible item. I'm going to wire the output of here to this input here. Now, the other important thing is that I'm going to also go to the input of this under this thing called the device name, right? I'm going to right click and create a control this time. Now, what does this do, by the way? Now, later you will see, I'm going to put this, okay, actually I could put it inside as well. Now, this device name will allow me later on to select, okay, the appropriate device that I'm using, whether it's device 1 or device 2, which you will see later on. Okay, and this thing will become more meaningful to you. So let me just resize this so that it's clearer for this presentation. Okay, so currently it's device number 1. If you select this, currently there's only one device 1, which device 1 is actually the simulated device. Now let's move on to here. Now, since this is an index array, I'm going to pull two of these elements here, as you can see, right? Because this index array itself contains two analog input values that I'm reading off from the hardware later. So I'm going to create a constant and create another one. So index 0 represents the temperature reading. Alright, for the AIO, which I'm going to type it here, let's use capital AI channel 0, which is the temperature sensor, right? Temperature sensor dash LM335. Okay, and at the same time, I'm just going to put it here. Now, at the same time, I'm just going to duplicate this thing here, because your Ai1 is the light sensor. I'm just going to put it here, HT, light sensor, right? And the output of this is in voltage as well. Right, so let's take a look. Now, remember that we need to convert the temperature sensor for the LM335, right? So what I'm going to do is that I'm going to multiply. I'm going to look for the multiplication function, right? Multiplication. I'm going to put one of these here, and I'm going to take the first input here, which is the reading for the temperature. I'm going to right click and input it into the the input function, and I'm going to multiply this by a factor of 100. Okay, this is what I'm going to do. And then, so this is the multiply function. Now I also need to get the subtract function as well, because I'm going to subtract the value by 273.15, right? So right click on your mouse, create a constant, right? 273.15. Okay, so that should give me, if I've done it correctly, this should give me the correct reading for the temperature. So let's try and put a waveform chart here. Call it the waveform chart. Maybe let's call it the LM335 temperature sensor, right? So that is one. Could possibly increase the size, right? Now what I'm going to do at the same time is I'm going to just resize it a little bit larger, and at the same time probably might be useful to just drop a thermometer. Let's put a thermometer here. Okay, let's put a simple thermometer over here, and probably now the temperature is not going to go up to 100, that's for sure. So I'm going to say put it to about say 35 degrees Celsius perhaps. Now the next thing I'm going to do is that I will wire the output from this subtract function, which is after it has been converted to the thermometer as well. So I'm going to show something like this, right? Let's click on this. Yeah, okay, it's fine. Now don't forget that the output of the second element, which is the Ai1, will be the reading for the light sensor. So let's go ahead and create another temperature chart. So what I'm going to do is right click, select the waveform chart again, put it down, right? So let's kind of resize it a little bit bigger, and let's call this the light sensor. Okay, shall we? Let's call this LIGHT, light sensor voltage reading. Okay, so let's do that. Okay, if I get this done correctly. Okay, so we are. Now, so what I'm going to do is that I will then wire that output, right, from the index array to the input of this chart here. Okay, I think we can comfortably go file and save as. Let's save this project. Call it the LM335 and light sensor. Okay, so that is the file that I'm going to call. Right, let's click OK. I'm going to test it now. So what I'm going to do is that I'm going to run. Now you would not expect to see any physical reading. Yep. You will not see any physical activity going on because this is running on a simulated deck. Excuse me. So now what I'm going to do next is that I'm going to connect the real deck. So I'm going to take the USB connector and connect it onto my PC. Right, you will see that as soon as I connect the USB connector onto my computer, you will see this dialog box that appears, right? As usual, I'm going to go to this configure and test this device. So it will launch my NI-Max. So you can see over here very clearly that the NI USB 6009 device number 2 has been connected. How do you know it's connected? You can see that the USB icon shown in bold and black color. So now I have the physical device connected. I'm just going to do a self-test, and it passed successfully. I'm quite happy with that, so I'm going to close this. Now, so let's try and go back to your lab view again. Now this time around, you will see that I'm able to select okay, the device 2. You see, this new device has appeared, right? Device number 2 is the physical NI USB 6009 hardware, which is my what I'm using is the LabVIEW, the blue color demo box that you've been using in the lab. right, which is connected to the various components like the temperature sensor, light sensor, and so on. So, and of course, device 1 is the simulated deck. So maybe it's good to just put a note here. This simulated DAQ, simulated deck, I call it USB 6009, right? And that's for device 1. Okay, and of course, device 2 is the real physical DAQ USB 6009. Alright, so with that in mind, I will just put a note here for convenience and to ensure that we are all on the same page. Alright, as you can see over here, so I decided to leave this note over here for you to see. Alright, so device 1 is the simulated deck and device 2 is the real physical deck. Now, so what I'm going to do is that I'm going to select the physical deck device number 2, right, and I'm going to try and run this LabVIEW program. Now what you can see, I do have a slight problem here. Let me try and fix it. Now we have the, you know why? I did not switch on the AC adapter for my DAQ demo box. So now what you can see is that I have some readings over here. Okay, let's take a look. Now the temperature reading, as you can see over here, is hovering between 24 and 25 degrees Celsius. That's my room temperature, as you can see over here, the scale, right? So this is the room temperature. Now let me try and put my finger or my index finger on the sensor itself. I would expect the temperature to rise, which is looking at the first chart there, the LM335 temperature sensor. Now I'm using the device 2, which is the real device itself. Now you can see that the heat, or you can't see, of course, I mean the temperature that is rising because of the heat that is transferred from my finger to the sensor itself. Now I'm going to release that. Now I'm going to try and use my index finger to cover the light sensor. Okay, you can see there's something that we're familiar in our lab when we were doing this, lab 3 or lab 4 actually. So I'm going to release my index finger. You see the voltage rises up again. So I'm going to cover it. Okay, so if I'm going to cover and remove it, you can see that I'm generating kind of like a pulse on the second reading there under the light sensor voltage. So it's showing this. Okay, so if I cover it completely, you will see that the voltage drops to about below 0 degrees Celsius, 0 volts, yeah, 0 over volts. Now I'm going to release that. The voltage rises back to about 2 volts, and that same goes for the temperature sensor. When I try to press my index finger and my thumb onto the LM335, the temperature will rise quite slowly. Right, so that's all for the video. Now I've successfully shown you how to create the simulated deck as well as the real physical deck using the device name, as you can see. So this is a very useful thing that we can do even when you are not in the lab. Right, when you don't have the hardware with you, you still can proceed to create the same as what we do in the lab. Now the other advantage of doing this is that you notice that the DAQ assistant doesn't really matter how you do it, because it allows you to create that simulated deck. And just by providing the device name, as you can see over here, it will allow you to determine whether it is the real simulated deck or the physical deck based on the device number. So with that, I think I will end my video or my recording here.